Okay, yesterday we did Thomson model and Rutherford model. So today we will study Bohr model of hydrogen atom. So Bohr give three postulates. Number one, in the first postulate, he says that every atom consists of central core called nucleus. So he says that every atom consists of nucleus. So here in nucleus, this nucleus is positively charged, so it has proton, and the electrons are revolving around the nucleus. Electrons are revolving around the nucleus with some velocity v. So this motion of electron around the nucleus is provided by a centripetal force. Let's say this distance is r. Okay, let's say here there are z number of proton are there, because atomic number, what is atomic number? Atomic number is denoted by z. This atomic number is number of proton. So here z protons are there, okay, in the nucleus. So this is positive charge and this electron is negative charge. So both of them are charged particle, right? Opposite charge. So opposite charge means they will attract, but the electrons are revolving around the nucleus. If this is because due to centripetal force, okay, here centripetal force is acting in this direction, and since this is a charged particle, both of them are charged, so there will be one electrostatic force will be there, right? We have studied in Coulomb's law, electrostatic force F in this direction, and centrifugal force will be in this direction. So since the electrons are revolving around the nucleus, that means this centripetal force and this electrostatic force are equal. That is why it can revolve around the nucleus. If centripetal force is more than this electrostatic force, then the electron will move like this, right? And if centripetal force is less than this electrostatic force, then the electron will move like this and it will collapse into the nucleus, but it does not happen, right? That means both centripetal force and electrostatic force are equal, so they are making a balance. So what is the formula for so first postulate is centripetal force is equal to electrostatic force of attraction. So centripetal force you have studied in class 11, right? So that centripetal force formula is mv square by r. So this is this radius. This m is mass of electron mass is m, velocity is v. So this centripetal force will be equal to electrostatic force. So what is electrostatic force will be 1 by 4 pi E naught q1 q2 by r square. So here 1 by 4 pi E naught. Q1 means first charge and second charge. So first charge is this one, nucleus. So electron and proton, they have same charge, okay, but electron is negative E, proton is plus E. Both of them are, the magnitude is same, only the sign is different, okay. So since there are z number of proton are there, so the total charge will be number of proton into charge on each proton. Charge on each proton is E, so it will be Ze. First one, Q1 will be equal to Ze, and Q2 is this electron. So charge of electron is E, okay. E. So this is the first postulate of Bohr atomic model. So this 1/4 pi E naught you can write as, here we have r square. So this r square, r is radius. 1/4 pi E naught you can write as k, okay, because this is a constant, so I can write k, okay. So it will become Ze, E into E square by r square. So this is the first postulate of Bohr model of hydrogen atom. So what is the second postulate? So in the second postulate, Bohr says that electron can revolve only in certain discrete orbit, okay. So again I will make electron can revolve only in fixed orbit, with some fixed orbit, okay. So this fixed orbit is given by, the condition for this fixed orbit will be the angular momentum in that orbit must be equal to, okay, angular momentum, okay, linear momentum is mass into velocity. For angular momentum L, okay, L is for angular momentum, it will be mass into velocity into radius, mvr, okay. Mvr is the formula for angular momentum. So this is r, mass of electron, velocity, okay. Here we have Z, okay, Ze, I will directly write Ze, okay. This is positive and this one is negative, So if the angular momentum is equal to integral multiply of h by 2 pi, this h is Planck constant. Here n is what? Integer, okay. So angular momentum is equal to integral multiply of h by 2 pi. So n is integer 1, 2, 3 like this. For first orbit, this is the first orbit, so n will be 1, okay. For second orbit, n is 2, so this is the condition, okay, that the electron can move in fixed orbit. So this angular momentum must be equal to n by h by 2 pi. For first orbit, mvr is equal to n is 1, okay, h by 2 pi. If the angular momentum is this one, then that electron will move in the first orbit, okay. If the angular momentum of the electron is 2h by 2 pi, that means 2 cancel, h by pi. If the angular momentum of the electron is h by 2 pi, that means that electron will move in the second orbit. Okay, every electron has its fixed orbit. So this is the second postulate. Now, what is the third postulate? Third postulate. Okay, this is nucleus, electron. Okay, first level. Okay, this is first energy level. Here n is equal to 1. Second energy level, n equal to 2. Now here the electron, see in the second postulate we have Bohr say that the electron move in fixed orbit. So when an electron jumps to higher energy level, okay, like this, from first orbit to second orbit, that means when an electron jump from one orbit to another orbit, it will release energy. Okay, either it will release energy or absorb energy. Okay, when it move from lower energy level to higher, it will absorb in energy. Okay, and when it move from higher to lower, that means from this point to this, that means the electron must, this electron must reduce its energy, so that it can move to lower energy level. Okay, because in first orbit the energy is fixed. Okay, let's say 10 electron volt is in the first orbit. In the second orbit it is 20 electron volt. Example, okay, just example. So 20 electron volt electron which have 20 electron volt energy cannot move in this orbit. Okay, first orbit, because here only 10 energy is how much? 10 electron volt. Those electron which has 10 electron volt energy can be in this orbit. Okay, that means this 20 electron volt electron has to give out some 10 electron volt energy, so that it will become 10. 20 minus 10 is 10. So when it release 10 electron volt energy, then its energy reduced to 10 electron volt. Then only it can move to a lower energy level. Okay, this first energy. Now for this one, so here we have 10 electron volt, and in this second orbit we need 20 electron volt. So when this electron from external source, when we absorb 10 electron volt, when this electron absorb 10 electron volt, then it already have 10 electron volt, so it will become 20 electron volt. So automatically it will jump to higher energy level. Okay, because total is 20, so 20 cannot be in this first orbit, it should be in second orbit, so it will jump to the next higher energy level, 20 energy level. Okay, so the energy absorbed or emit by the electron is given by h mu. This is not v. Okay, this is mu. Energy in second orbit minus energy in first orbit. So this is the third postulate of Bohr atomic model. So now it also have some limitation. So limitation of Bohr atomic model. The main limitation are this Bohr atomic model is apply only to those atoms which has atomic number 1. Okay, if it is more than, if the atomic number is more than 1, then this is not applicable. Okay, this model is not applicable. So this model is applicable only to those atoms which have atomic number 1. Okay, example hydrogen. Hydrogen atomic number is 1, right? Number second limitation is this according to this model, it cannot explain. Using this model, it cannot explain why electrons are revolving in circular orbit. It can all see there is many possibility, right? It can revolve like this also, but according to Bohr, the electrons are revolving like this, right? It cannot explain why electrons are revolving in circular orbit. So, and it also cannot explain the spectral lines. Okay, same as Rutherford. So these are some of the limitation of Bohr atomic model.